Investment and interest rate. As we saw in the previous video, the investment spending is a function of interest rate. And we also know that investment is inversely related to the interest rate. More specifically, we can write an investment function, which is I is equal to I bar minus BI, where B is always greater than 0, right? B is followed by a negative sign. That is why the slope is negative. But B in itself is greater than 0. And I is the rate of interest. B is the sensitivity. You can write here only the sensitivity or the responsiveness of the interest rate. I bar is the autonomous investment spending. So when interest rate is 0, then investment is equal to I bar. Now, the negative slope just reflects the assumption that as interest rate decreases, then investment increases and vice versa. So there is a negative relationship between interest rate and investment. Now, in this diagram, we are going ahead in the inverse of what we were doing. Now, please understand this thing, and I want to, spend a moment on this. This is important because a lot of students get confused here. Now, if I see and if I tell you what our last diagram was, ideally I had investment here and interest rate here, right? And I said that, this is I bar when interest rate is 0. Then I have investment equal to I bar. The slope is B and my function is negatively sloped. This is what I told you. Now, this is making much sense because investment depends on interest rate. Interest rate does not depend on investment. You are first given an existing interest rate from the central bank, from the government, from the different banks. Based on that level of interest rate, you're going to do investment. And this is what the function looks like. And then we said that, as B increases, then I will have an investment function which becomes steeper and steeper. And as B decreases, we'll have an investment function flatter and flatter. However, whenever we have to plot this investment function, especially whenever we have to plot anything where one of the factor is a price, for example, the investment function, the demand function, the supply function, we always kind of plot inverse of those. So we plot inverse investment function. I will, kind of keep telling you how and why this is important. But actually, we go ahead and take interest rate here and investment here. This is a bit tricky to understand. Although on the y-axis, we always take the dependent variable. On the x-axis, we always take the independent variable. But just like the demand curve, where, price doesn't depend on quantity. Quantity depends on price, but I take price on the y-axis and quantity on the x-axis. I am trying and doing a very, very similar thing here. And then I go ahead and I again plot a downward sloping investment function because obviously I understand that it is negatively sloped. So the slope is negative. But here is the thing that you have to understand. See, when I say that I is equal to I bar minus BI, if I have to write this in terms of I, what will I get? I will get I is equal to I minus I bar. So my BI will come here and this will become I minus I bar. And I will be 1 upon B I minus I bar. So this would be minus 1 by bi bar plus 1 by bi. This is how I'm going to go ahead and write my investment function. And I can actually go ahead and kind of tell from here that, you know, investment and interest rate are still negatively related because this is inverse now. This is inversed. But now I am telling you what happens to the slope with the line. So please take one more example. Suppose I tell you y is equal to 40 plus 1 by 2x. And I tell you y is equal to 40 plus 1 by 3x. In this case, just understand this thing. My b is actually in the denominator only, right? So suppose I tell you y is equal to 40 plus 1 by 2x, y is equal to 40 plus 1 by 3x, and I ask you to plot this thing. So you will first make a schedule. For the first one, you will say when x is 0, y is 40. When y is 0, x is minus 40 into 2, minus 80. And similarly, you will make it for the other one. So you will tell me that when x is 0, y is 40. But when y is 0, x is minus 120. So if I have to plot this thing, then when x is 0, in the first case and second case, y is both 40. But when y is 0, then x is in one case minus 80 and in the other case minus 120. If I join this, which of the two lines is a flatter line? This one. So which came out to be flatter? This one. Mathematically, I'm just explaining you. So which is flatter? Whichever has higher denominator becomes flatter. Whichever has higher denominator becomes flatter. So I understand that this becomes a flatter line. The same is the case here, because I'm not finding direct investment function, but I'm actually finding inversely inverse relationship between investment and interest rate. I can go ahead and say that if b increases, b is coming in the denominator, b is this, sensitivity is 2 here, sensitivity is 3 here, and so on. So sensitivity is just what is coming in the denominator. So if b increases from 2 to 3 to 4 to whatever, then my inverse investment function that I have drawn here, this keeps on becoming flatter. So if I go here and I check in the investment interest plane ki jagah, if I'm checking interest investment plane, then the higher the b, the flatter is my investment curve. So this is higher b, this is even higher b, this is lower b, this is even lower b, and this will make sense to you. How? Supposedly take any interest rate. Say interest rate is 5%, and here say interest rate is 4%. Suppose I ask you what happens when interest rate increases from 4% to 5%, and I take it here. In this case, when I have a very steep investment function, I'm just going to compare this versus these two. So when I have a steeper investment function, my investment decreases by this amount. When I have a flatter investment function, for the same change in interest rate, my investment decreases by a huge amount. So here I am being more sensitive the moment you increased interest rate by 1%, the decrease in investment went by a huge amount when my investment curve was flatter. So which means that the flatter the investment curve, actually in the inverse space, the more sensitive I am to changes in the interest rate. So let's go ahead and check this back. So I am saying that B is the responsiveness and I have a negative slope. And now I'm going ahead and saying that I is equal to I minus BR. And there are two things that is going to determine my investment function. One is the slope and one is the level of autonomous spending. Slope has two aspects to it. If you are highly responsive to interest rate, which means if B is high, then investment schedule is flat, because for the same change in interest rate, there is huge decrease in the investment whenever interest rate increases. So if B is high, then investment function is flatter. In the I space, just remember this. If B is low, then investment is steeper, again in the I space. So if investment is little responsive to interest rate, then investment schedule is closer to being vertical. Imagine if it is completely vertical. Suppose I tell you investment schedule is this, then whether the interest rate is 4%, 5%, 10%, you will do the same amount of investment. You're not at all sensitive to interest rates. So that's the first aspect. The second thing that your investment will depend upon will be the autonomous spending. When investment in itself increases, so at any interest rate, when you want to invest more, then the investment schedule will shift to the right. Similarly, if you decrease your investment, then the investment schedule will shift to the left. Because then you are saying that, you know what, at any given interest rate, I am increasing the level of my investment. So if at any given interest rate, you want to invest more, then your investment schedule will shift out. If you want to invest less, your investment schedule will shift back, but the slope will remain unchanged. So this is about the two things. Schedule in. So, this is, you can write inwards shift. Here you can say outward or right shift. It will shift to the right. In both the cases, you should know that here the slope is unchanged. And here actually only the slope is changing. I bar is constant. Okay. Thank you.